Okay, good morning. So let us start the new lesson. I think this lesson is not hard at all for you because it's very similar to what you have already learned. You have started learning about sequences, I think, in Math 1C. I don't know how much you remember. So under the title of arithmetic progression and geometric progression. But I'm not taking those things for granted, of course. I will start from scratch, but I just want to tell you that this is more or less more tangible topic for you. So what do I mean by a sequence of numbers? It's just a list of numbers, okay? But the order matters here. So might be the most famous sequence of numbers is just this sequence, yes? I have 1, 2, 3, 4, 5, and etc. So, so this is a list of numbers, so we can call it a sequence, yes? So there is no obligations about the properties of the numbers that you're using. So you can use any number that you like, okay? And then arrange them in an order, and then this becomes a sequence. So for example, if I call this sequence A, even if I change these two numbers and 2, 1, and write 3, 4, 5, and then continue exactly the same way afterwards, and I call this in sequence B, because I have rearranged the first two terms, it means the order of the numbers that appear here is different from the order of the numbers that appear there. So by definition, I would say that these two sequences are not equal. Okay, so that's important to know. But except for that, you can choose any numbers you like. And then when I say, for example, in this case, it is not very clear what is the meaning of these three dots mean. Yes. Because when I use these three dots, it means that whatever pattern you discover so far, it will continue like that after that. Yes. Yeah. So that is why we usually work with sequences in which there is a regularity or pattern among the numbers. Okay, but in principle, you can just randomly throw any numbers that you like there and list them as a sequence, then that becomes a sequence. For example, I don't know, I can write the third square root of 3, the third root of a square root of 3, the third root of 2 plus 2, then I can write tangent of 59 degrees. I don't know, then I can write logarithm of 5 in base 2, and then of course this is also a sequence. But first of all, immediately you realize there is no meaning to put these three dots there, because there is no way for me to guess what's coming next. But my point is that it doesn't matter which numbers you put in a list, that list is called a sequence, okay? The list of numbers. And the order matters. So if you rearrange them, it becomes a new sequence, even though the numbers you are using are exactly the numbers that you are using in the previous sequence, okay? So sequences are sensitive to order, okay? The second thing that, of course, sequences like this is useless for us. There is no point for us to study these sequences because they are completely random. So if you want to study sequences, technically, we have to study sequences that have some regularities or patterns among them. Otherwise, what we are supposed to study. Okay? Okay. So that is why we usually don't, of course, at all look at these sequences. Another thing that is very important, if possible, and that is called the general term. Term of a sequence, if possible. Or sometimes it is common to call it for short the nth term. Yeah, sometimes we call it the nth term. Sometimes we call it the general term. What is the meaning of that? Because when I write a sequence like this is the first term in my sequence, which I called it A. To denote that, I put A, meaning that this is from sequence A, but then I put an index a little bit lower, and I write A sub 1, it means the first term in sequence, which is called A. Okay? And then how do you read this? A sub 2 means the second term in the sequence, which is called A. Yes? For example, If I ask you what is b sub 2, what is the answer? B sub 2 means that the second term for the sequence which is called b. This sequence is called b, so when I say b sub 2, you should go and find the second term. The second term is 1, so b sub 2 is just simply 1. That's the notation that we use. So if I have a sequence which is called a sub n means the nth term. The nth term of the sequence A. And of course you understand that. Can n be, I don't know, does it make sense to say n is 1, 5? No. But does it make sense that A5 is 1, 5 in general, not in this sequence? So in general, the numbers can be any kind of numbers, but these indices should be positive integers or natural numbers. Okay, for example, if I have another sequence, so let me call it C. Let me write 1, 1 over 2, 1 over 3, 1 over 4, and of course here you can guess what is coming next. I don't know, have you seen these IQ tests that you have a bunch of numbers, you're supposed to discover the pattern and guess what is coming next, okay? Okay, so what is coming next? It is 1 over 5, yes? So can you find the general term of this sequence? What do I mean by that? I want you to write C sub n for any given n. It means that you need to write a formula here for me so that when I start putting n from 1, 2, 3, etc., it starts generating these numbers one after the other. Okay? And this is common. I don't know, in some books, n starts from 0, which is a little bit odd because when you write C sub 0, it means the 0th term, which is not very good convention. Unfortunately, in your book, n starts from 1 as my convention. Okay? So what should I write here? Yes?
1 over n.
1 over n. Okay? Why this is a good formula? Because if I replace n with 1, 1 over 1 is the first term. If I replace n with 2, it becomes 1 over 2, yes. The second term is really 1 over 2. If I replace it with 3, it becomes 1 over 3, and that is correct. The third term is 1 over 3. So that is called the general formula for this sequence, or sometimes we call it the nth term of the sequence. Okay, but what about this one? If someone writes this formula, do you accept it? It's not totally off, but it is not acceptable for this sequence. Why? Because I told you that you have to start always from, n starts from 1. So the first number that you put is 1. But when you put 1, what happens? It generates 1 over 2. Okay? So if I ask you, what is the list of numbers generated by this formula? Can you tell me what is the list of numbers generated by this formula? So if you don't mind, let me write it dn. So it becomes 1 over 2 first, and then 1 over 3, and then 1 over 4, and then 1 over 5, etc. So, and then you see that this sequence and that sequence are not the same. Only of course, the difference is only it starts with 1 over 2, but this one starts from 1. But anyway, these two sequences are not the same. Okay? So the idea of the general formula is something like that. You need to find a formula so that it generates the whole list without skipping any one of them, one by one, if you replace n from 1, 2, 3, etc. Okay? And of course, I don't want to emphasize here. So for example, sometimes you can't find them and sometimes it is not that easy. Let us try to test something for fun. This is not the focus of the lesson, of course. For example, this one is easy, not hard. So can you write a formula for this 1 over 2, 2 over 3, 3 over 4, 4 over 5? Of course, I am completely sure that you can immediately guess the next one. So what is the next one? What is the next one? So let me call this sequence E. If I ask you that what is the next one, you can immediately guess. When you can guess, in principle, you can write the formula. So what is the next number coming in that list? Everyone. What? 5 over 6. So can you write a formula for any term? So let me write E but let me write sub n. So can you write a formula here for me? Of course, I put the fraction line because you can see that all of them are fractions. But how should I write this down? Yes, ma'am? N over n plus 1. Yes? How can you check that what you said is correct? Yes? You try from n equals to 1. This is essential. You have to start from n equals to 1. If you put n equals to 1, then what happens? It becomes 1 over 2, and that is correct. The first term is really 1 over 2. And if you choose n equals to 2, then it becomes 2 over 3. So that's correct. And then hopefully you can convince yourself that's a good formula for this. Yes? What is the benefit of having the general formula? You can immediately answer all sorts of questions probably related to the sequence. For example, if I ask you, continue this list, what is the term number 100 in this list? If you have the general formula, so you can immediately write E100 is equal to. So what do? You have to replace n with 100, and then it becomes 100 over 100 plus 1, which is 100 over 101. So you see that if I have the general formula, and if I am interested to find any term of that sequence, what I need to do is just replace n with that number, and then I calculate and find the term. Is that clear? Okay. What else? For example, can you write a formula for this sequence? So let me call it. Let us start from A. So I have a sequence like this: 1, minus 1, 1, minus 1, 1, minus 1, etc. Can you write a formula for this that generates this sequence? I told you that my focus will not be on this kind of things, but it is not hurting if you can have a little bit of fun to see if you can discover the formula. Can you discover a formula so that generates this list 1 minus 1, 1 minus 1, 1 minus 1, one after the other? Anyone else? Yes?
Is it minus 1 to the power n plus 1?
Minus 1 to the power. So you are saying that a sub n is minus 1 to the power of n plus 1. Yes? That's correct. Yes? But let me ask first, do you think that this formula also works? No. Why this formula is not good? Because when I replace n with 1, what do I get? I get minus 1, which of course is not the first term. So this is enough to show that this is not correct formula, okay? But it is not that off. Why? Because if I put 2, what happens? It becomes 1. And if I put 3, it becomes again minus 1. And if I put 4, minus 1 to power 4 is 1. So it generates a list similar to that one, but it is not exactly that list because it starts from minus 1, even though it alternatingly goes from minus 1 to 1 and 1 to minus 1. So that formula that Melvin said fixes this problem by adding 1 unit here. Yes? Now what happens if I replace n with 1? It becomes minus 1 to power 2. Minus 1 to power 2 is minus 1 times minus 1, which becomes positive 1, and that's correct. And of course, it is clear the next one will generate minus 1. Because if the previous one was even, the next one will be odd, and the next one will be even, the next one will be odd. So I will have this alternating gymnastics here, yes? So that's correct. So that is the formula, general formula for this sequence, yes? Yes?
Does n minus 1 also work?
And here we have a lot, yes? So you can write, for example, some of you might write it like this. That's also correct. And some of you might write it like this. It's a good question, by the way. We do not have usually this kind of freedom. Okay, but this is one of those cases we have a little bit of freedom to choose whatever we want to. So all of them will work. Yes? Any questions here? Okay, so let us see what can you do with this one. What about this one? B. Let me have 1, 0, 1, 0, 1, 0, 1, 0, etc. Okay, can you imagine a formula that generates this list now? Okay, let me make it a little bit simpler by putting 2. Well, might be, I don't know if that is simple for you. This time, let us put it 2 here. Okay, 2, 2, 2, 2. I don't know if this is a little bit simpler or not. We can solve the other one later. can you imagine that the formula generates this list? No. So that's what I'm saying. This is not the focus of our lesson. This is just for fun, okay? But I want you to understand, using these examples, I want you to understand what is the meaning of the nth term. Yes? Any clues? So something around this, you need to think something like this. Okay, so let me write it because there is nothing that I can help you with. So Bn is something like this. Do you think that this is correct if I write it like that? No? Why not?
Because then
The first one becomes 0. But what about the second one? The first one, if I put n equals to 1, this becomes 1 minus 1, which is 0. Of course, this is clear that it is wrong because it doesn't generate the first one correctly. Okay? But it is not that off. Yes? Because the first one is 0, but what is the next one? Number 2. It's 2. So it's 0, 2, and then it becomes 0, 2. Okay? So you need to adjust it. So it is not that bad, but it is not correct. Yes? So can you fix it now? Yes?
you have minus 1, 2, and
Well, yeah, so you mean like that. Yes, that works. Yes, let us check. If I put n equals to 1, b number 1, it's 1 plus minus 1 to the power of 0. But becomes 1 plus 1, because minus any number to power 0 is 1, and it becomes 2. So at least for the first one, it is correct. And let me calculate b2. b2 means, what should I do? It becomes 1 plus minus 1 to the power of 2 minus 1, because b is 2 in this case. But then it becomes 1 plus minus 1, which of course is 0. And I think you can convince yourself immediately that this will continue like this. Why? Because if I go to the third one, what happens? This power from being odd becomes an even power. And whenever it is an even power, minus 1 to the power of that even becomes 1, and 1 plus 1 is 2. So it is clear that this pattern will continue, yes? 2, 0, 2, 0. So that's correct. So this we will take it as the formula for that. Is that clear? Okay, but can you solve the other one now? I think this should be simple for you now. So if instead of 2, 0, 2, 0, I have 1, 0, 1, 0, 1, 0. So what do you think about this one? Yes?
1 over 2 plus minus 1 to the power of n minus 1 over 2.
Yes, so it means that the only difference here is that what is happening, all the terms of that sequence are correspondingly being multiplied by a half. So if I multiply every number in this sequence by a half, I hope that you agree that that sequence B will turn into this sequence C. So this is also true for the general term. So it means that Cn and Bn differ by a factor of 1/2. So it becomes 1 plus minus 1 to the power of n minus 1 divided by 2. You can check it yourself. For example, if you put 1, it becomes 1 plus 1 divided by 2, which is 1. But if I put 2, it becomes 1 minus 1 divided by 2, which is 0, and it will continue like that. Okay? So that's a little bit about understanding about the general term here. Okay? Any questions so far? Okay. But there is also an alternative way sometimes to describe a sequence, and that is called a recursive definition, okay? A recursive definition of a sequence. Okay, so that is something, I don't know, have you already seen that or not? You know, when I usually teach math 1C. Okay, let me ask one question because I was solving one question in math 1C. Can you guess the formula for this one? So let me see. I start from 1, so let me call it sequence K. Okay? So this is a math 1C problem, okay? So 1, and then I add, if I remember it correctly, I add 1 unit to it. Then I add, so let me see. No, I start from 2. And then 6. And then 12. And then, so 2, 6, 12, 20. Let me write one more for you. 30. Okay. And 3 dots. So first, let us take it as the IQ test. Can you guess the next number? This is one question. The second question is that, can you find a general formula for this sequence? In the case that we just learned. This is a Math 1C. It is a level 3 problem in the Oracle book of Math 1C. We just solved that, I think, last week. Okay, so 2 questions. Can you guess the next number coming? It is easier, of course, than generating the formula. Yes, please. 42. So how did you come up with this idea? So yes, that's correct. So I think, yeah, 42 is correct. But what is the idea that you realized? What is the pattern you discovered so far? Yeah, so you for example, you told yourself probably the increase that you see here is 4 units. Yes, the increase that you see here is 6 units. The increase that you see here is 8 units. Yes, the increase that you see here is 10 units. Then immediately you discover the pattern. So the next time, how many I should add? 12. And when you add 12 units here, it becomes 42. So your guess is correct. So at least you understood the pattern. What might be this pattern in its own is not enough to guess a formula that generates this list from the first term up to the nth term. Now, can you guess that one? Yes, please.
N times n plus 1.
N times n plus 1. So this is another pattern you discovered, which is not only enough to guess the next one, but also enough to guess actually the whole pattern. So yes, so another way to look at this, so this is probably, was it the way that you thought about it? Is that I described, was that one you described or no? No, I mean, this was the pattern you just told me. Okay, so that pattern is working, so because you guessed it correctly. Okay, but now, if you want, I hope that you agree with me, if you want to continue this pattern, you can immediately guess the next one, the next one, the next one. But might be it is not that helpful for finding the formula that generates all of them, yes? But if you see this pattern, that 2 is what? 1 times 2. What is 6? 6 is 2 times 3. What is 12? 3 times 4. What is 20? 4 times 5. What is 30? 5 times 6. And then, as you said, you can immediately guess 1, 2, 3, 4, 5. The next one is 6. 2, 3, 4, 5, 6. The next one is 7. Yes? So this becomes 42 again. So that's another pattern. Okay. But this pattern will help you to guess what is k sub n in general. What is k sub n? N times n plus 1. Let us double check that. Do you agree with this formula? Yes? Because if I put n equals to 1, it generates 1 times 2. If I put 2, it generates 2 times 3, 3 times 4, etc. So that's the correct formula. Yes, is that understandable? Okay. So let me also immediately tell you this question before going to this. This is also Math 1C problem. Okay, so I don't remember exactly what was it, but let me just give you some flavor about it. So a sequence an is given very simply as 2n plus 5. Okay, so this is the general formula for a sequence A, and I give you another general formula for a sequence for B. Yes, I would say, for example, let us make it very simple. So n minus 2. Okay. And then they define Cn to be this sequence, A sub n plus 2 plus Bn plus 1. Okay, so the question is this. I have two sequences, A and B. I have given you the general formula for the first and the second sequences like this. And I have defined another sequence C whose nth term is obtained from this relation. Okay? I want you to understand this symbol that I have used here. Okay? So you see that n plus 2, both of them are lower than the baseline. So n plus 2 is the index. Okay, be careful about n plus 2 and an plus 2 are different. Okay, so they are not the same thing. This is the index. It means term number n plus 2. But what does this mean? This means term number n plus 2 units. Is that clear? So this is the difference between these two symbols. If I ask you what is Cn, can you write a formula for Cn? How do you proceed? First of all, tell me, is the question clear? So I have two sequences. These are the general formulas for sequence A and B. I haven't given you the formula for sequence C directly in terms of n. I have defined C sub n in terms of sequences A and B in this way. My emphasis here is to understand this symbol and differentiate it from this symbol. Let me repeat. This symbol means term number n plus 2, whatever n is. For example, if n is 1, this means term number 3. If n is 5, this means term number 7. Yes? But what is the meaning of this one? This means whatever an is, you add 2 units to that. So this is the difference between these two symbols. So make sure that you understand that. Okay, so let me clean this here. Now, how should I write Cn? I want to find the formula for Cn. Yes? Okay, so Bn and 1, they are not big problems. Yes, 1 is just simply 1. So let me copy and paste that one there. And Bn is directly given to me, which is n minus 2. Okay, but I want to wait for you to tell me, what should I write for A sub n plus 2? Yes?
2 times n plus 2. So it's like 2 times parentheses n plus 2 plus 5.
Plus 5. Yes, so that is exactly the same thing. Because let us ask you, what is A number 10? If I give you this formula and I ask you for A number 10, what you are doing, you just take n off and replace it with 10. 2 times 10 is 20 plus 5, 25. You answer immediately 25. If I ask you, I don't know, what is A7? You replace n with 7, so it becomes 14 plus 5 is 19. So you can answer that. Now, when I say A number n plus 2, what you have to do the same thing. You have to replace the given n with this index now. The index is n plus 2. So what you write here, you write 2. You take it off and put the whole index there, which becomes n plus 2. Yes. And then I add what? I add 5 units to that. So, any questions here? And then I simplify that. So let us just do the simplifications fast. 2n and n is 3n. 2, 4, 9, 10, and then 8. So that is C sub n 3, 8. 3n plus 8. Yes, is that clear? Yes? Okay. Now let us go to this topic. Recursive definition of a sequence. Sometimes the best way, the most that we can have about a sequence is having its general formula. But sometimes life is not that easy. We cannot have the general formula, but we can define it recursively. What do I mean by that? I mean like this. For example, I would say that A is a sequence. A is a sequence, and I give you the first term. A1 is, let us say, is minus 3. And then I say that A sub n, if n is greater than or equal to 2, is equal to. So let us say 2a n minus 1, and then plus 7. Okay, so you see, this is a recursive way of defining sequence A. So you see, this is, you don't think that this is the general formula. Is this a general? Do you see the difference between this example and the example we had so far? In the previous examples, an was given as a formula written in terms of n. But here, an is given as a formula not written in terms of n, written in terms of a sub n minus 1, which means the previous term to an. Okay, so this way of defining the sequence is a recursive definition of the sequence. It is better than nothing, but it is not that powerful as if I have the general formula. For example, in this case, if I ask you what is a number 10, you immediately were able to answer 25. But if I'm crazy enough to ask you the same question here, then it is not that easy to answer it immediately, but it is not impossible. It is not impossible. You can do it, but you have to do it recursively. How? Let us make it short. Let me calculate A5. Let us say that someone has defined this sequence A in this manner, and they ask you about what is A number 5. Okay, so what is A number 5? Okay, there is nothing I can do here because this is giving me information regarding 1, the first term, so I have to start from here. Okay, so I replace n with this 5, hoping that I can find a 5. But then you see what the problem is. So if I replace n with 5, what happens? Can you tell me? What should I write on the right-hand side? 2 times what? A4. Because when I replace n with 5 on the left, to keep the equality, I have to replace every appearance of n with that 5. So when I replace this n with 5, n minus 1 is there, so n 5 minus 1 is 4. It becomes 4. But did I solve my problem? No. Because to answer a 5, I need to know a 4, which is still I don't know. So I have to recursively calculate this. So I would put a 4. So I replace n with 4 this time. What happens? It becomes 2a, everyone. What happens? 3 plus 7. Can I answer this right away? No, because I don't know a3. So I have to do it once more. So a3, what should I write? 2a, 2 plus 7. Is it enough? Not yet, because I don't have a2. But now I write a2. What should I write? 2a1 plus 7. Is it enough now?
Yes.
So this, because a1 is given now to me, yes? So I can find a1, I already have a1, so I replace it here. It becomes minus 6 plus 7 is 1. Do you agree? And now that I found a2, I go backwards. I put it here, because a2 now becomes 1. I put it here, it becomes 9. Yes? And now that I know a3, I can go one step back and then put it here. So what will happen? It's 18 plus 7 is 25. Yes? And then finally, I can answer my question by plugging this back there. So it becomes 2 times 25 is 50 plus 7 is 57. So it was not impossible to answer, but I hope that you agree this become boring. So if I have asked you what is a number of 500, it is in principle simple, but very, very boring. But in that case, even if I ask you what is a number 500, the answer is 2 times 500 plus 5, 1005. Yes?
Isn't it possible to find a general?
Yeah, that's a very, very good question. Okay, so that's a very good question. That's a natural question to ask. So is it possible? Is it systematically always possible that if someone defines a sequence recursively, analytically and by calculations and wise thinking, is it possible for us to find a general formula rather than a recursive formula for the same sequence? And the answer to this in principle in general is no. Because you can make this as complicated as you want to, okay? And that the answer is no. But there are some classic ones that you can do that. For example, this is among the classic ones. This is not topic of the lesson, so I don't want to go through it. So there are some kind of recursive relations that are called classic ones, and mathematicians have already thought about that and devised a systematic way to do this. Okay, but this is not part of your lesson, so don't worry about that. But I want you to know that in general, the answer is no. It is not possible for any randomly recursive definition I find the general formula. So it's not possible. Yes? But of course, this is one of those classics. Might be you can also find it yourself. So can you find a formula instead of working with the general sequence? But before going further, I want to tell you that this is not always the case that you always define with one recursive. So this is one step backward. Sometimes you define it with 2 step backs or 3 step backs. That's up to you. For example, one of the famous sequences is called the Fibonacci sequence. Yes. So the Fibonacci sequence is defined in this way. Fibonacci, if I Italian mathematician Fibonacci. I think something like that. Okay, so Fibonacci sequence is defined like this. Let me put little f for Fibonacci. F1 is defined to be 1, and F2 is defined to be 2. Again 1. And then F sub n, the term number n, of course, if n is greater than or equal to 3, because I already defined F sub 1, I already defined F sub 2. I want to define you what happens afterwards. So F sub n is defined to be F sub n plus 1 plus F sub n minus 2. So be careful, there is no why question why you define this. No. Someone, I don't know, for some reason was interested in this sequence, and that is called the Fibonacci sequence, okay? But the important thing for you is that you see there is a little bit difference from here. How many steps I need to go backwards? There, here, a, n, term number n is related to term number n minus 1. So every term is just connected to its previous term. But here, term number n is not only have something to do with the previous term, but it has something to do with the previous term. Okay, so here we have to go 2 steps back if I want to know that. For example, but how do you interpret this? You say that Fibonacci sequence is a sequence that starts with 1 and 1, and from after that, every term is the sum of 2 previous terms. Yes, that's if you want to read it in words. So if I want to generate the sequence, can you have the list? 1, 1, and the next one is 2. Why? Because when you want to write f number 3, so let us do it analytically here. I want to know f3. So I have to replace n with 3. But when I replace n with 3 here, I have to replace n with 3 everywhere. So this becomes f, 3 minus 1 is 2, plus 3 minus 2 is 1. Can I calculate f3 now? Yes, because f1 and f2 are directly given. So this becomes 2. One more. So if I ask you calculate f4, the only thing that you can do is just to write this formula for n equals to 4. So this becomes f3 plus f2. Can I calculate f4 now? Yes. Could I calculate f4 directly? No, because in calculating f4, I need f sub 3. But so I have to do it step by step. That's the bad thing. So what happens, f3 is what? F3 is, I just calculated to be 2. f2 is already given to me 1, so when I add them it becomes 3. So then you see that the first term is 1, the second term is 1, the third term is 2, the next term is 3, and of course you can guess what's coming. 5, what's next? 8, because every term number n is the sum of 2 previous terms. So if I want to go here, I have to go backwards 2 steps and add them, it becomes 13. And then this continues. Yes? So that is the Fibonacci sequence. And of course, this is also among classic ones. So mathematicians actually found a way that no matter, so you can say that if I have a sequence, let us call it alpha n, if I have a number a, alpha n minus 1, plus b, alpha n minus 2, so this is among classic examples that mathematicians were able to find a systematic way to find a general formula for the sequence alpha n. And it is also fun to see what is the general formula for n. Can you guess a formula, by the way, here? Can you guess a formula that generates those list of numbers one by one without ignoring any one of them? You want to have a formula, do you remember, like this? Let us pretend that we want to do such an exercise for this sequence. It is hard, and that is why you really need a systematic way. This is not always possible just looking at this to guess. Okay, let me write this, at least it's good to have a fun here. So this is very complicated formula, but you cannot even probably guess. It's 1 over square root of 5, and then you have this combination. 1 plus square root of 5 over 2 to the power of n, minus, if I remember correctly, okay, that's the formula. Okay, so it is really strange. If you don't have this idea where these numbers are coming from, it's very strange. But so could you guess something like this? Okay, so that's what I'm saying. It's good that mathematicians already designed those methods, but let us try to understand this. So if I ask you f1 using this formula, what is your expectation? If this formula is really correct, it will generate what? 1. It should generate 1, because we know already that f number 1 is 1. Let us double check. So if I calculate f number 1, I have to replace n with 1 everywhere. So then it becomes 1 plus the square root of 5 over 2 minus 1 minus the square root of 5 over 2. Yes, do you agree with me? But can you see that this is correct? Because the denominators are the same, so I would write, sorry, this is 5. So I would write the common denominator to be 2, and then I repeat this, 1 plus the square root of 5, minus the numerator of the second one, but this minus sign goes for this one and that one, so it becomes minus 1 plus the square root of 5. Yes? And now what happens, this one and that one are cancelled, so I have 2 times the square root of 5 in the denominator, because I am multiplying them, and the square root of 5 is also 2 square root of 5, so it gives me really 1. So at least it works for 1. Okay? But I want you to feel that this is a very strange formula. So let us calculate f2. So I want you to see that how this becomes very complicated in calculation. So f of 2, it becomes 1 over a square root of 5. So what should I write? I have to replace every occurrence of n with 2. So, but before calculating, what is your expectation about the number if this formula is supposed to be correct? Again, 1. Why? Because Fibonacci sequence is defined in that way. Yes? To the power of 2. Okay, how can you calculate this, by the way? It's a little bit hard math 1C problem, but in principle you should be able to calculate this. Yes? So how we calculate this, by the way? So how should I calculate that to see that this is working? So I have to expand, yes? Let us just do this. So it's 1 over square root of 5, and then I have a fraction here, raised to power 2, the numerator to power 2, the denominator to power 2. So it becomes what? The denominator to power 2, the numerator to power 2. The second one the same. Okay? So can you guess this number is exactly equal to 1? But let us calculate. Okay, so the denominators are the same, so I copy and paste this one. I put the same common denominator here. And then I have to use the squaring rule to square this. So it becomes the first one squared, 2 times the first one times the second one. And the second one squared is 5. Okay, I will do the same thing for that one, but be careful. There is a minus sign here which will affect all the terms. So the first one squared is 1, but because of that minus sign, it becomes minus 1. 2 times the first one times the second one is minus 2 square root of 5, but because of an extra minus sign, it becomes plus 2 square root of 5. And then finally, this one to power 2 is positive 5, but because of this minus sign, it becomes negative 5. Yes? And let us simplify things a little bit. This 5 and that minus 5, this 1 and that minus 5 are gone. So this multiplied by that is 4 square root of 5. And then 2 square root of 5. 2 square root of 5 is also 4 square root of 5. And as we predicted, it correctly becomes 1. Okay, but I hope that you understand this becomes extremely complicated. For example, if I want to calculate the third term, I recommend you, if you are a math nerd, I really want you to calculate it at home for yourself. So can you confirm? So what is your prediction for this one?
2.
Yeah, it should be 2. But it is easier said than done, yes? Yeah, try to convince yourself that that number is 2, okay, in principle. Okay, so these are mainly general informations. You shouldn't be scared about these kinds of complexity, but I want you to understand the meaning of recursive definition of a sequence. And then if a recursive sequence is given to you, let me give you another example here. So if I give you a sequence B, let us say B1 is 2, B2 is 0, and let me define you Bn is Bn minus 1 plus 2Bn minus 2 plus 2n. Okay? So this might be given to you. Of course, here I have some limitations. N should start from 3 because I already know B1 and B2. Let me make it simple. If I ask you what is B4, okay, let me wait for you to calculate this precisely and give me the number. So I have defined you sequence B recursively in that way. Even if I didn't mention it is defined recursively, by looking at it, you feel that this is defined recursively, yes? Yes, yes. Yes, yes. So please try to do that yourself and then we finish this part. Is it clear that what I have written, n minus 1 is the index, n minus 2 is the index, but 2n is there. And when I type them, by the way, n minus 1 and n minus 2 are being typed automatically with a little bit smaller fonts. So that's also good to realize that. Did you get the number? Yes? 18? Okay, let us wait for others to see if that's correct. Anyone else? 18? Yes, is that correct? So apparently it should be correct then. I'll wait a little bit more. Okay, so I think we have to solve this problem, and I hope that many of you got it right. So if I want to calculate B4, of course I start from B4. So it means that I replace n with 4. Not only this n, every appearance of n should be replaced by 4. So what happens? This becomes B3 plus 2, B what? 2. But then 2 times 4 again. Because when I replace n with 4 on the left side, I have to replace every appearance of n with 4. So then it becomes clear. But it is not enough yet because unfortunately I have B2, it's given, but B3 is not given. So it means that I need B3. So I have to go and ask myself, okay, what B3 is. I have to replace n with 3, so it becomes b sub 2 plus b2b sub 1, and 2 times 3. Yes? But this is a good starting point, because I need b2 and b1, I have both of them. So b2 is 0, plus 2 times 2, and plus 2 times 3 is 6, so it becomes 10. Yes? And then I have to put it back here. So I continue now. So I couldn't continue here before I do the next step. So B3, I just got to B10, so I put 10 there. And 2 times B2 is given directly 0, and 2 times 4 is just simply 8, and then your answer is 18, so that's correct. So that's 18, yes? Is that clear? So it's very simple, it's not hard at all. Okay, but now there are 2 sequences of numbers that are very famous in mathematics and extremely simple, okay? One of them is called an arithmetic sequence. Arithmetic sequences. The other one is called geometric sequences. In principle, you should have known these words from previous courses, but as I told you, I will not take it for granted. I start completely from scratch. Okay, so let us start today. I don't think we will be able to finish. I think we need 2 or 3 sessions for completing this part. So today we want to talk about arithmetic sequences. Okay, an arithmetic sequence is a very simple type of a sequence, and that is a sequence in which every term is obtained from the previous term by adding a constant to it. The same fixed constant. Let us correct myself. So as arithmetic sequence is a sequence in which every term is obtained from the previous term by adding a fixed constant number to it. Okay? So what does it mean? For example, the probably most famous arithmetic sequence is the sequence of natural numbers. So you see, if I want to go from 1 to 2, what is added to it? 1 unit. And then the same 1 unit is added here to help me to go to the next step. The same 1 unit is added here. The same 1 unit is added here. Yes? So every time a fixed number, in this case 1, is being added to the previous term to be able to get the next term. Yes? So that is called an arithmetic sequence. And this constant number that is just added every time is called the common difference. And it is denoted usually by just little d. Okay, so I say that this is an arithmetic sequence. If I call this sequence A, the first term is what? 1, and the common difference here is also 1. And if I ask you to determine the sequence, an arithmetic sequence, in principle, what pieces of information you need to understand the whole sequence? If it is an arithmetic progression or arithmetic sequence, yes? 2 pieces of information. Where should I start? And what is the number that I have to add? In principle, if I give you a sub 1 and if I give you d, you understand what is your arithmetic sequence. By the way, I use the word progression. That is also common. But there is a little bit difference from progression and sequence. A sequence in mathematics is a list of infinitely many numbers continued forever. But when you say progression, it means that you start at some point, but you also terminate at some point. This is a little bit technical difference. But sometimes in this course, I use these words interchangeably. Okay? Any questions? Okay, but let me give you another one. So let us write one. So what do you think here? So I will have minus 5, then I will have minus 3, and I have minus 1, then I have 1, then I have 3, then I have 5, etc., etc. Do you think if the pattern really continues like this, do you think you see an arithmetic sequence on the board? Yes. What is the starting point? So B sub 1 is what? You see it. And what is D here? D is 2, yes? Because every time I add 2 to this, I add 2, can you please close the door, thank you. So I add 2 units to this, If I add the same 2 units, I will get the same thing. The next one, if I add the same 2 units, that is important. This number is not changed. Do you remember a sequence we discussed before? Do you remember 2? What was that? And the next one was 6. No, was it that? 1 times 2, 2 times 3, 3 times 4, yes. Yes? So you see that what Emma actually mentioned was correct. So in this case, 4 was added. The next step, 6 was added. And the next step, 8 was added, yes? Do you remember something like that? So this is not an arithmetic progression, even though you can understand that every number is being obtained from the previous one by adding a number. But the point is that this number is changing. For an arithmetic progression, that number that I'm adding all the time is fixed. So it is very simple sequence. It doesn't have any complications at all. So what should I do here? B1 is minus 5, D is 2. Okay? And then, what happens if D is 0? What happens? Yes? Everyone, just say it. What happens if D is 0? I generate the same number over and over again, and there is a name for this sequence. That sequence is called a constant sequence. A sequence in which all the terms are equal. That's called a constant sequence. And a constant sequence is not interesting to study because it is very trivial, yes? If I have a sequence of all square roots of 2, square roots of 2, square roots of 2, etc., if I ask you what is term number 100, what is that? The square root of 2. So you don't need to study to answer that. If I ask you what is the sum of the first 10 terms of this sequence? 10 times the square root of 2. So this is why, even though technically speaking, D equals to 0 is also acceptable, but it is not something very interesting. So usually when we are dealing with arithmetic progressions, we assume that D is not equal to 0. But I'm saying it's not, how do you say, disallowed or unallowed? Which one is correct in English? Disallowed? Yeah, okay. So anyway, by the way, we can also have negative. So don't think that these should be very friendly number. Might be you can have this situation. For example, I start from square root of 2, for example. Then I will have 0. Then I will have minus a square root of 2. Then I have minus 2 square root of 2. Then I have minus 3 square root of 2, and continues like that. Do you think that's an arithmetic progression? Yes? But what is D here? Every time. So every time I am adding which number? Minus the square root of 2. Yes? And then again, I add minus the square root of 2. Then again, I add minus the square root of 2. And the same thing. So if I ask you if this sequence is called C, what is C sub 1? Is the square root of 2. And if I ask you what is D in this case, what's the answer? Minus the square root of 2. And what happens if D is positive? If D is positive, the numbers will increase. If D is negative, the numbers will decrease. Yes? Is that clear? Okay. Now let me ask you one question to connect this idea to this new idea so that we have to play around with the concepts to implement these things in our brain, yes? So can you define an arithmetic sequence recursively? So what is the question? Let us first understand the question. So let us say that you have a sequence which is an arithmetic progression. And I give you the first term. Let us say the first term is any given number. And I also give you the common difference. Okay? Can I define this sequence recursively? Of course, this is not a wise plan to do that because we prefer, if we can find the general formula, we prefer the general formula rather than forcing to define it recursively, okay? But this is just a matter of curiosity so that you can work with these concepts so that you can understand them better, yes? So let us give you numbers. For example, let us say that A1 is 5. And let me give you D to be 3. Okay? First of all, can you generate the list of numbers for me? You start from 5, the next one is 8, the next one is 11. So what you are doing every time, what is the next one? 14, am I right? Yes, it continues. So this is the idea. Now what you want to do, A1 is directly given. So you want to say, what do I do to get AN? What do I do to get AN? That is the meaning of recursive definition. If I want to get AN, what should I do? What should I know first to be able to get AN? When I ask you what is coming next, if I didn't give you this 5, could you guess the second one? If I didn't give you 5, just with 3, you couldn't guess. So you need a starting point. So how did you get 8? You add 3 units to 5. How did you get 11? You added 3 units to 8. So now the question is that for finding the third term, you add 2 units, you add 3 units to the second term. For finding the second term, you added 3 units to the first term. So if you want to calculate the term number n, what do you do? Everyone, yes?
You add 3 units to a minus sub n minus 1.
A, exactly. So that is the recursive definition, yes? So a sub n is the previous term plus 3. Okay, so in general, you can define every arithmetic progression recursively, but it is pointless because we prefer the other way around. Okay? But we always prefer to do it because we can very simply discover the formula for any arithmetic progression. So let us say that I have an arithmetic progression that the first term is A1 and the D. So someone gives me the first term of the sequence and gives me the D, and that person asks me about how can I find AN directly, not recursively. Okay, how can I do that? Let us find a pattern. So A1 is just A1. Okay, so if I want to say what is A1 to the person, I would say that, okay, A1 is the same A1 you gave me. But if I want to give A2 to that person, what do? I will take A1 from that person, I will take D from that person, add them up. Whatever it is, I will give this back to the person. But if the person asks me about A sub 3, what should I do?
A1.
I take A2 recursively and add D to it. But this is not good for that person because that person will complain that I didn't give you A2, I just gave you A1 and D. So it means that you continue a little bit more because what is A2 itself? A1 plus D, so it becomes what? A1 plus D, which is A1 plus 2D. And then this person gives me A sub 4, and then what should I do? Recursively, I would say that A3 plus D. But I want you to understand, you are not allowed to give this number to that person because immediately that person will complain. Because he will complain that I gave you A1 and D, but you are telling me A3 plus D. What is A3? Okay, so then what I do, I would say that, okay, to shut him down, actually, I would say that A1 plus 2D plus D is what A1 plus 3D, yes? And now, hopefully, you can see the pattern going on, and then you can continue and then guess the general pattern. Yes, if you don't mind, let me artificially add 0D, because 0D is just 0. The reason that I'm doing it, because I want you to see the pattern. And if you don't mind, instead of writing D, let me write 1D, and then look here. So A1, 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 A1. A1 appears in all of them. So hopefully you guessed that A1 also appears here. And then you see D appears in all of them. So you see that D also appears here. But what is the coefficient of D? If the index is 1, the coefficient is 0. If the index is 2, the coefficient is 1. If the index is 3, the coefficient is 2. If the index is 4, the coefficient is 3. Now that the index is n, what do you guess? N minus 1. And this is one of the formulas in the formula sheet, okay? So this is the general formula for the arithmetic sequence or progression. So either you memorize it or you can read it from, but you need to know what is the benefit of that. So if someone asks you, what is this? In words, in English words, you would say that this is the formula that enables me to give term number n in arithmetic progression with term number 1 a sub 1 and common difference d. Okay, that is the formula that we can answer such questions. So let us solve some very simple problems here. Okay, so let us give you an example. Determine an arithmetic progression. So let me write like AP for arithmetic progression. Determine an arithmetic progression whose seventh term is minus 10 and its 20th term is, I don't know, so let us write minus 60, something like that. It's a very simple and standard question. I told you that this section doesn't pose any problems for you, hopefully. This is very simple. Okay, but what is the meaning here of determine? When do you say that I determine the sequence, an arithmetic sequence? You know the sequence, you know an arithmetic sequence if you know the first term and you know D. Because if you know the first term and you know D, you know whatever you need to know about the sequence, yes? Okay, so how should I solve the problem? I would say that, okay, you are telling me that term number 7 is minus 10. So how can I translate that? It means A, if A is the name of my sequence, A number 7 is minus 10. And you are also telling me that A number 20 is what? Is minus 60. Okay, so how can I get some information from here? A sub 7 is minus 10. But there is a formula in the formula sheet for arithmetic progression. Why I am allowed to use this? Because it is mentioned it is arithmetic progression, so don't get confused. Okay, so A sub 7, it means that replace n with 7 in the formula. Okay, A1 you don't know, so you have to write A1. But instead of n minus 1, you write 7 minus 1, which is 6, and D you don't know yet. That's it, equals to minus 10. Okay? And then you translate the same thing using the same formula. So A number 20 means what? I have to replace n with 20. I don't know A1, so I copy and paste A1. But when I put 20 here, 20 minus 1 is 19. And then this is D again, and it's equal to minus 60. And then how many unknowns you see? You see 2 unknowns. How many pieces of information you have? Exactly 2. So I hope that it is not hard for you to see that I set up a system. And solve the system. I don't know how do you want to solve the system, any way that you are comfortable. But I myself prefer to multiply this by a minus sign and add it here. If I do that, this minus A1 and then A1 are cancelled. So let us just do this in our head. It is not hard. So remember, I multiply everything up there by minus sign. It becomes minus A1 minus 60 positive 10. And add them side by side to this one. Minus A1 cancel that one. Minus 60 and 19D becomes 13Ds. And this becomes positive 10. And this becomes negative 60. It's negative 50. Yes? So what happens for D? D is just simply minus 15, minus 50 over 13. Okay, and then when D is found, you put it in one of these formulas and then you find A1, because determine means finding both of them. Okay, so what can I do? Instead of A1, I just write A1, but plus 6 times D. So I have to multiply this by 6. It becomes minus 300 over 13. It is supposed to be minus 10. So I move this to the other side. So A1 becomes 300 over 13 minus 10. And if you calculate this, so A1 becomes 170 over 13. These numbers were not easy to guess at all. So I intentionally give these numbers. Might be that if the numbers are simple, you can guess, but guessing these numbers were not easy. But systematically, we can find. Any questions here? Understandable? Okay. So let me ask you another simple question, but I usually find students answer this wrong if they want to answer it immediately. So for example, how many numbers you can see in the following lists? How many numbers are in the following lists? If you want, I can emphasize of arithmetic progressions. Okay, so let me just write simply something here. So I don't know, let me start with 23, 24, 25, 26, and I continue my list up to 93. So where I put these dots, it means that I'm not deceiving you. So it means that whatever pattern you found, it continues like that. So how many numbers you see in this list? How many are tempted to say 70? If that's the case, it is not the case. Yes? So that's why, this is my experience. Usually people say immediately 70, which is not correct. Yes? If I ask you, write the numbers from 1, including 1, up to 10, including 10. Okay? And if I ask you how many numbers are there, what do you say? What do you say? 10. Okay? So you don't say 10 minus 1. But somehow, for some reason, I don't know, this is probably because of evolution or something. Because this is very common. Even when I was teaching back in Iran, people also said that. I don't know why. So it is a widespread. So this is, if something like this if a trait of this type happens, probably it's because of the evolution or something else. I don't know. But anyway, so 23, 24 up to 93. So you did the logic correctly. When I wrote the numbers 1, 2, 3, 4 up to 10, and I asked you how many numbers are there, you just answered 10. You didn't do 10 minus 1. But for some reason, if I ask you the same question for this, you do the same thing. You just write my 93 minus 23. Okay? So there are how many numbers there? 71. Okay? And the reason is that if you want to understand it from this perspective, it's not hard. First of all, do you see a list of arithmetic progression here? Yes? What is the common difference?
1.
The common difference is 1. So what is the first term? So this is the first term in my sequence. This is the second term in my sequence. This is the third term. This is the fourth term. And if I continue, I reach to 93, which I don't know which term is that, so I call it a sub n. And then I ask myself what n is. Yes? Is that understandable? Okay. But can I use that formula for this problem? The answer is yes. This is important to it. Not now, because this is the only sequence that we are dealing with right now. But in the future, we'll also deal with geometric sequences. So you need to know if you are using the formula, why you are allowed to use the formula. You are allowed to use this formula in this context because this is an arithmetic progression. Okay, so what do? You write the formula an is equal to a1 plus n minus 1d. And then you look at the information. What do you have? Do I know an? It's 93, even though I don't know n. Do I know a1? Yes, that's 23. Do I know d? I don't know n, so let us copy and paste. Do I know d? That's 1. But look what happens. When you move this to the other side, I intentionally write it like this. 1 times n minus 1 is what? N minus 1. So when you answered naively before that the answer is 70, 70 is not n. 70 is n minus 1. But you want to find n. What does it mean? You have to move minus 1 to the other side. So it becomes 93, 23 is equal to, as plus 1 is equal to n. So you see that's the reason. The n that you are interested in is not the last number minus the first number. It is the last number minus the first number plus 1. And that is exactly the way. So, of course, this is simple. I intentionally wrote it like this that you understand your mistake. But then the answer is 71. Yes? So there are 71 numbers in my list. Yes? Is that right? Okay, so let me write another one.
I think lesson
Lesson has finished. Okay, so we stop here. Any questions? We'll just wait, please, so that I can pause the video.